Hey everybody, I hope you're having a great conference so far. My name is Jessica Sachs, and thank you for coming to my talk, The Last 20 Years of Web Testing. My goal with this talk was to answer the question I get asked all the time, Jessica, why do we have another test runner? I used a test runner 10 years ago. It did the same exact thing that we do now. What is so good about this new tool? What was wrong with the previous thing we used? I used it, it worked. And the answer I have to people is that our needs changed. And this talk is basically explaining that. What particularly changed, Jessica? We're still shipping websites. Server-side rendering was a thing in the 90s when people wrote web applications in C. I'm not kidding. It is. It's called CGI, the Common Gateway Interface. Anyway, so this talk breaks down the history of the web in the context and lens of testing, right? So every era that you would normally have in a web history talk of hey, in the beginning, we used C to write web applications. There's the parallel question. Okay, you wrote them in C. How did you make them? How did you make sure that they worked before you shipped them? So this talk has a very long version. It's about an hour and a half. I learned, because this is not the first time I'm recording this. We're not going to do an hour and a half. We're going to zoom through this in about 18 minutes. And to do it, we're going to cut down the web history into 3 chunks, right? So the first half, between I call it the beginning through about 2007, would be the click-through era, where you click through stuff, you roll over to your coworker's desk and be like, hey, this is the web app. And they're like, that looks great. And then we have the 2 eras of browser war 1, where we're trying to fight against IE and Netscape. And there's a lot of platform inconsistencies in that side. Browser war 2. Everybody's like, oh, Firefox is great. We start with Firefox is great. And then we end with Microsoft Edge is all right, Chromium. So those 3 eras of web development are really important and influential. But as far as they affect quality, we can kind of shorten them into browser consistency was hard. And we have end-to-end tools now and browser automation labs, like device labs like Sauce, that allow you to spin up browsers on a VM somewhere and click through things. But generally, those browser inconsistencies don't affect us anymore as much because of the consolidation on Chromium. So that's, 20 years of the web history, kind of shortened. But now, around 2007 to 2024, things get interesting as far as the motivations of browser test runners and node test runners. So that is what we're going to focus on for the rest of this talk. So when I prepared for this talk, I interviewed as many people as I humanly could. I posted on Twitter, I got hundreds of responses, I messaged, the writers and authors of some of these really old frameworks. There's a test runner I didn't even know about called JS Test Driver. It was written in Java by Google, or at Google by somebody who was, smart and googly. And that ended up being the first test runner of record that I could find where somebody was able to do the workflow of having an IDE, spinning up a browser, and on file change, writing code and seeing it rerun. So that workflow end to end of your JavaScript code is running in a browser after you hit Command S. That thing. That was possible in around 2007. It led the way, ideologically led the way, for another tool that is what most people got started with. So most people started writing tests with Karma or Jasmine or Mocha. And those things started around 2011. And Karma was also written at Google. It had a different name. This is a history talk, so we're going to talk about some of the nerdy things. Karma's original name was Testacular, the test runner with balls. That was the official name, and I thought about ripping this from the talk so many times, but I find it so funny. They still pay homage to it on the homepage of Karma. Every time you see Karma, the spectacular test runner, that's kind of a joke back to the name, which Google had changed after the community, namely Ryan Florence, was like, hey, by the way, do you think maybe we could pick something less juvenile, because I'm trying to get people to take unit testing seriously, and I'm already having a hard time with that without all of your jokes. So Karma was the first experience people had where a node-based runner would generally perform the same workflow as JS test driver, but it was different because of the infrastructure requirements, right? You don't need Java on your continuous integration machine anymore. You have a node-based runner. So you've just cut the complexity of the CI runner like way down. You don't need the JVM. That's big, right? That's like a gig. Now you can do everything you need within your node executable. Sweet. So that's Karma. That's the beginning of testing and the JavaScript testing culture. It caught on because the Angular team, took Karma in and said, hey, everybody, this is JavaScript unit testing. This is how you can write tests in JavaScript. And that was a huge thing. It was the first time web developers, were thinking, okay, maybe writing tests is worth it. Because before then, they had been in this manual testing, regression matrix hell of trying to find the right browser versions to test on what operating systems and what CSS quirks to work on. They weren't thinking about functional unit testing. That just wasn't something people did because the cost and overhead of actually like getting the final sign off, that final check mark to be like, yeah, it works. Most of that cost was in the manual testing process. So writing unit tests wasn't helpful to velocity, right? So if you were to pitch, hey, I would like to write unit tests prior to 2011 to your boss, right? Because it was technically possible. If you were to make that pitch prior to 2011, they would be like, why? Why would you want to write automated tests for a feature you're going to have to heavily manually test on every single browser? There was no standardized environment that would make unit testing actually improve your velocity or really stability meaningfully enough. But once Karma came along, the overhead cost of like getting it up and testing and doing continuous integration wasn't that bad. It wasn't that much of a velocity or productivity hit, so people started doing it. So Karma lived for a very long time. It was the main test runner until Jest, but Jest, while it was written in 2011, it was closed source when Facebook first wrote it, and it was open sourced in 2014, and only eclipsed Karma in 2016. So it took a minute for Jest to overtake Karma, and between those two runners, and then Mocha and Jasmine, everybody started around there, right? Node-based runners like Jest are in their own era. And I kind of mark that as the creation of JS DOM, which happened about, 18 months after Node was released, JS DOM was released. And JS DOM is just like an emulation library so that when you're in Node, the word window doesn't, throw an error when you type it in the console. That's it. It assigns different things that we would expect in a browser to work, like, create an event or create a DOM node. Those things are now possible if you load JS DOM into the top module scope. So once that emulation library became possible to use, lots of different developers started writing test runners, right? So we had Ava, we had Tape, we had Mocha, and then we had Jest by Facebook. And these were great in comparison to Karma, for the simple fact that to get Karma to run in CI, you needed a browser, right? Karma was great if you just ran it locally, right? It was lovely. You would open up your browser, Karma would open up your browser for you, and you would see the tests run and be like, this is great. I can debug them in the browser. The same environment that your application is going to run in, you can debug your tests. And that was super awesome, except for when you went to run in CI, you weren't running on your browser in CI. You were running in this thing called Phantom.js. And Phantom.js was a C++ written browser, headless browser. So it liked to crash all the time. It was very persnickety. On architectures, and it was difficult to debug locally when there were failures. You would have differences between the Linux box that you ran it on and your OS X or Windows box that you were trying to debug the quirk on. There was a lot of shift in environment, and it made it very difficult to use. It was also slower. Like it would have like reconnection issues. It was just slower than the alternative, which was a node-based test runner on a node-based emulated DOM. The stability in Jest and other node-based runners far outweighed the benefit of working in your own browser environment. And that's honestly a bummer, right? That's a bummer that I think we're still kind of trying to work through, and is why the third era of test runner, the environment-aware test runner, I hope will solve the node-based emulation issues. So far, we have Karma. Karma's overtaken by Jest, mainly because of Phantom.js stability issues. Headless Chrome eventually solved these issues, right? It didn't make it super fast because you're still spinning up Chrome headlessly, but it solved the stability issues. But namely due to the instability of Phantom.js, Jest took over the market. And Jest was great until we had issues with module loading and transforms. And this was the thing that really sparked the next generation of test runners that you're seeing in the market right now. So ESM, the TLDR is, ESM is why the import statement either does or doesn't work in your code base, or why top-level await either does or doesn't work in your code base. So Jest struggled with getting ESM support for years, like over 4 years. I still don't know if it truly has module support. I stopped looking, and this is like the industry I pay attention to, and I stopped looking. So Jest struggled with ESM support, and it struggled very, very strongly with transpiling files that were not React JSX or TSX files. So as a Vue developer, we always struggled with transforming single file components in a way that was production-like to the Vue compiler, right? Like we would have to re-implement the Vue SFC compiler specifically for Jest. And there are other frameworks like Svelte or like Solid or other front-end frameworks that don't behave like React does, or have different file extensions that need different transforms. And Jest required you to re-implement your compiler just for your test runner, just for that test runner. If it would have reused Webpack, sweet. If it would have reused anything that was easy to plug in, that would have been great. But when Jest was written in a time where there were like 6 bundlers, right? There was like Browserify, there were Gulp, Grunt, Babel, Webpack, Parcel. There were a lot of different ways that people were trying to load code and transform code. And so when Jest was created, I think they just picked an option that wasn't opinionated. They were just like, let's pick an abstraction. Let's choose an abstraction and go with that. And that was a great choice for the time. But now, as we are really adding more and more business logic and complexity into our bundlers, it's safer for our tests to reuse that configuration. And this is when environment-aware runners, with Vitest being the crown child here, with Vitest being the best example, this is when environment-aware runners really shine, is the idea of, hey, what if we reuse our build configuration, but also for our tests? Wouldn't that make so much sense? And compilers and build tools that do this have an advantage of being able to support many different runtimes as well. So if you can say, hey, I'm going to eventually run this function in a Vercel edge function or a Cloudflare worker environment, you can make your node environment or your VM as constrained or as open as you would like it to be. And that gives you the production-like environment that you need, and it surpasses all of the problematic false positives or false negatives you might get if you were in an environment that was a little drifted. It's not exactly what you're going to ship. If you don't remember to, disallow certain node methods because you're going to, ship browser code to a user. If you don't remember to constrain your environment, your test environment, you might accidentally ship broken code. Like, unless you manually went through it, right? You can't trust your test environment if it is not very close to production-like. And Jest and other node-based runners that do not plug into your build system or your module system kind of promote that drift. And so as more and more test runners like Vitest or like Buns Test or Node Test, as more and more of these environment-aware test runners come up, I think that they promote a safer way to test and build your applications. And so now we are shifting away from Jest and other detached, I don't have a good word for it, agnostic. They were well-intentioned and agnostic to the environments that were of the time. But I believe the shift that we're doing now with environment-aware runners is really it's really meeting us where we're at as far as the fact that JavaScript literally runs everywhere, and we are going to transpile our JavaScript for any number of environments. And the person that knows best, or the process that knows best about that, is going to be the thing that's compiling. It's going to be the runtime, it's going to be the compiler. And for that thing to have as much information as possible about how to scaffold up a test environment, that's the smart move, I think, to do for architecture and design for the test runner process. So that's my bit. That's my bit about environment-aware test runners and node-based test runners. And in the before times, it was, we didn't even talk about the library test runners that nobody used except for like the Yahoo UI guys. Because while I started the talk saying nobody really tested before 2011, that's true for like application developers, but there's a very weird history niche of people from 2011 and below that were like the people who wrote jQuery. Like, what did they do? And they did write unit tests, and they were like the only people who wrote JavaScript unit tests, but it was possible. It was 100% possible, but I have skipped it. I've omitted it for brevity. It's in the slides. If you feel like researching it, you can go through my slide deck. It has much more content than I can fit in a talk. But I'm going to leave you with a bit of a mental exercise. So there's something I like to do every once in a while. The premise of this talk, right, was if you take a timeline of like the history of web development and the history of testing things that were being developed, there should be like a parallel track, right? Of like, how do you test the things that you ship? Or how do you test before you ship them? So every technology advancement has a parallel question of what are the implications for testing it? So let's take something topical and say, there's about 4 things I think that are interesting right now. There's the commoditization of AI developer tooling, right? We tend to be generating some of the code we write. And then we also have things like, developers are owning more of their infrastructure. So like IAC, right? We have TypeScript developers writing SST code to deploy infrastructure to the cloud. That's a thing that exists. We have developers writing more TypeScript code in general, right? Does that have any implications for testing? Yes, you'll start to see DTS files and DTS tests becoming more of a thing over the last year. There's different testing libraries to test your types as we start to consider that to be part of the contract of code we're writing. And so the thing that I think is really interesting is what's going to happen to test tooling. What's going to happen to test tooling as AI becomes a thing? So there are already companies that are like, oh, we're going to use AI to like make the way that we tests fit better, right? So we're going to there's 2 companies right now that I know of that are like, hey, let's fix how we find selectors, right? So not doing ugly XPath stuff. Let's make accessible selectors so that when you find things on the DOM, you can easily do so. But that's kind of a problem that we already have. One of the things I want to think about is a lot of the application code that we're writing right now ends up being some of the application code. It depends on what you're working on, right? But many of us have started to build little ChatGPT OpenAI wrappers, yeah? And the most critical code that you write in that API request to your little ChatGPT buddy is the prompt and the words that you put in the prompt. And how do you validate, aside from manually testing, How do you validate, aside from manually testing, if your prompt, quote unquote, works? If it is giving the desired behavior to the user? How do you know that somebody hasn't accidentally typoed it and is going to start being rude to people? Right? It sounds silly, but like, go with me on the thought experiment, right? So the most critical code that we're writing is plain English in which we describe to a machine how things are supposed to work. And when you think programmatically, you're like, how do you test that? The tools we have right now, the only tool I can think of that isn't manual is to snapshot the contents of your prompt and be like, when we change this, we have to review it manually. And that's because no tooling exists right now for that problem. So I'm interested in the general facet of how tools evolve. I'm interested to see what happens in about 2 years to test tooling that'll allow us to test the things we're actually building, right? Because we're building different things. And when we build different things, we have to adjust our tooling, or at least our processes, and be like, hey, we just simply can't test this well with confidence until somebody makes something. So I think we'll see more test libraries. I think we'll see more test tooling for different things like DTS testing. That stuff's already happening because it's much easier than the problem of how do you test a model. So I think we'll see more and more stuff. And I want to impart on you the general concept and philosophy that you can figure out what to expect. You can figure out what to expect in testing if you just pay attention to the trends that exist in normal software development. So that's my talk. I hope you enjoyed it and have a good rest of the conference.